So for our last partial project, we were asked to solve two trigonometric integration by using identities. So these are the two that we chose. One was a little bit easier using sine, and then the second one is a little bit more complicated using cosine and sine. And we're gonna explain this later on. So we must remember that when we talk about identities, there are a lot of identities that we can choose from, but looking at our problem, we know that we're going to use somewhat the one that has a sign involved in it. So there are two options that we can use once we figure out which identities we can use. This one or that one. So in order to find out, we have to continue developing the problem. We have analyzed the problem. We know that the identity that we must use is sine of 2x equals 1 minus cos 2x. Once we identify the identity that we need, we can move on to begin with our problem. So the first thing that we run into is that we have a cube and a square. So in order to solve this problem, you have to separate the signs. So your problem is gonna look like this: sine x 6x sine of x squared times sine of 2. Okay, now you can already see somewhat of a resemblance to our identity, so we can begin to solve the problem. So we already know from our previous experience that this is a type sine u du. And this will be solved using our identity. Okay, so now that we have identified which of our terms is which, we're just gonna copy this exactly the same. So and we're gonna focus on this one. So this, using our identity, is gonna convert into 1 minus cosine squared of x squared dx. So once we have done this, we have to multiply our terms. So you're gonna be left with 6x sine of x squared minus 6x sine of x squared cosine squared of x squared dx. Okay, so now you have already simplified as far as you can simplify, and like we established before, this is a sine u du, and this is a u and du type because we have our cos square over here. So in order to solve a sine u type problem, we first need to write down our u, which is x squared. We write down the du, which is the derivative of our u, which is 2x dx. And in order to find out the things we need in our box, we need to write down the remaining information, which is 6x dx du. And in order to find out the box, we need to divide the 6x with our du. So we write down again 2x dx. And we start crossing out the information that cancels. The x cancels with the x, the dx with the dx. And so 6 divided by 2 is 3 with du. After finding out the information from our box, we rewrite the integration, which will be 3 sign, since it's a sign type, u du. We're gonna solve first the u and du before integrating completely this problem. In order to solve a u and du type, first we identify our u, which is cosine x squared. So right here, cosine x squared. Our du will be the derivative of the u, so it will be -2. Let's always remember that when you change from cosine to sine, you have to change it into a negative sign. -2x sine x squared dx. And after that, we need to find out our box information, so we rewrite the remaining information, which is 6x negative 9 x squared dx du. Negative 6x, let's always remember the negative. And we start dividing. We write here the negative, we rewrite here our du. Negative 2x sine x squared dx. And we cross out the information that cancels. Sine x squared, dx, dx, dx and dx. So -6 divided by -2 is equal to 3 du. And we rewrite that information in order to integrate. Integration sign 3. Let's remember, since it's a u and du, we write the u squared du. So in order to integrate, we need to change from sine to cosine. Let's remember that I change it to negative, so equals sine 3 negative cosine. We're gonna rewrite our u, that is x squared plus 3. Since it was u squared, we change it to u3 over 3, and we add the c, always at the end. We're gonna rewrite our final answer, which is gonna be -3 cosine x squared plus the 3 cancels, so it's gonna be our u, which was cosine x squared, cosine 3, because it's in here, x squared plus c, and that is going to be our final answer after integration.
Okay, first we have this problem that says the integral of parentheses cosine of 2x plus parentheses all to the 4th power sine 2x. Since the derivative of cosine is sine, so our u will be cosine of 2x. So u is equal to cosine 2x. The du, the derivative, will be negative sine 2x by 2, because it's u prime 2 dx. Now this will cancel with this one, because it's sine of 2x dx. So this cancels, this cancels, this cancels, this cancels, and this will remain at 1/2, because here is an imaginary like 1, and here is the 2, but since this is negative, you put a negative and with a du. So now we do integral we put this one here, negative 1/2 u, since the exponent is a 4, this will be a 4, and du. And now we are ready to integrate. So, it will be negative 1/2, but first we are going to do it in terms of u before replacing the u. 1/2 u to the 5th power, because it's 4 plus 1 when we integrate, and this exponent we place it also in the denominator, so here multiplying the 2 plus the constant. So now negative u to the 5th power over 10 plus c. And now we replace the u, that is this one, so it will be negative cosine of 2x to the 5th power over 10 plus c. And that will be the answer.
So in conclusion, we learned that when it comes to trigonometric integrals, we need to be very careful when analyzing the problem, because we learned that you can easily mistake which method you have to use. So always be careful when analyzing the problem to see if it has to be a normal substitution or you have to do substitution and identities.